Here's a clever little demonstration that illustrates the interplay between buoyant force and weight. Watch what happens when I squeeze on this bulb and increase the air pressure on the surface of the water inside this flask. Inside the flask there's a inverted test tube, and watch what happens when I squeeze on the bulb. When we try to understand the motion of things, we go through a little recipe. We first try to identify an object, isolate an object, and then once we found an object, we try to identify the forces on the object. And then from identifying the forces on the object, we determine whether the motion will be accelerated motion or whether the object will remain at rest or in uniform motion. The object I want to focus on in this particular case, the Cartesian Diver, is this test tube inside the flask. It's inverted, it's completely open on the bottom, and if you look at it you'll see that in the top of the test tube there's a little bubble of air, and then there's water filling approximately half of the test tube. Now, to identify the object is a very important thing, and so the object we want to identify is this test tube. And we want to imagine in our mind that we've put a little a plane across the bottom to define where the bottom of the object is. And so it's the test tube plus the water that's in the test tube plus that little bubble of air. Okay? Now that's the object. There are two significant forces on our object as it sits here. One is the weight of the object, which is downward, and one is a buoyant force, which is upward. And as the object just sits there, the two are in balance, and the object is at rest and remains at rest. When I squeeze on the bulb, I increase the air pressure on the surface of the water, the top of this, right up here in the top of the flask. That pressure is transmitted through the fluid down to the bottom of the test tube. So right at the bottom of the test tube, suddenly you see an increase in pressure. And that forces a little bit of water up into the test tube. And now the object has a little bit more water in it, and the bubble of air at the top will have been squeezed down a little bit to make room for it. If we look at our object, test tube plus the water in the test tube plus the little bubble of air, we'll see an object that now weighs more than it did before because of the additional water that's been pushed up. Consequently, the forces, the weight downward and the buoyant force, are suddenly out of balance. The weight is increased, consequently it wins in some sense, and the object then moves downward. But when I release the pressure, then the opposite occurs. Suddenly there's a little bit less pressure at the bottom of the test tube. That means that a little bit of the water now is forced out by the bubble of air, and the little bubble of air gets bigger, the amount of water a little less than it was before. The weight of the object then decreases, and for a moment then the buoyant force wins, and the thing moves back upwards. And by alternately squeezing and releasing, we can cause the Cartesian diver to go down and up and down and up again.